So a little video lesson of the standard angles on the unit circle. The unit circle is a circle of radius 1. So what we're going to do is we're going to put a couple of these standard angles, these special angles, into the unit circle. So it'll be 45 degrees, 60 degrees, and 30 degrees. So the unit circle, again, circle radius 1, and so we have the 4 quadrants. We're going to start with the 45 right triangle and see if we can figure out what those coordinates on the unit circle x, y are at 45 degrees. So what we do is we isolate the 45 right triangle with a radius or hypotenuse of 1. And then we're going to use the Pythagorean theorem. And you can see using the Pythagorean theorem we have legs of x, so it's x squared plus x squared equals 1 squared. And simplifying all of that, we actually find out that each leg is the square root of 2 over 2 if we do all this simplification, also known as rationalizing the denominator. So then this leads us to be able to basically get the coordinates of every 45 degree angle inside that unit circle. What we have to do is look at, in quadrant 1, both x and y are positive. In quadrant 2, x is negative, y is positive. In quadrant 3, both x and y are negative, and in quadrant 4, x is positive, y is negative. The next thing I want to do, so that was the 45. Also, one other thing let me say about this. So the equivalent of 45 degrees, 45 degree analogy in the second quadrant is 135 degrees. And in radians, that's 3 pi over 4. 45 degrees in the first quadrant was pi over 4. And then in the third quadrant, the 45 degree analog is 225, which is 5 pi fourths. And in the fourth quadrant, the 45 degree angle analog is 315, and the radians is 7 pi fourths. All right, we can do the exact, well, not the exact same thing. We do a similar way to calculate the legs of a 60-30 or 30-60 right triangle when we have hypotenuse 1. And what we're going to do is we're going to create an auxiliary figure. So we're going to make a duplicate figure and attach it right next to this 60-30 right triangle. And so our duplicate figure also is a 30-60 right triangle. But notice that that means I have 3 interior angles of 60 degrees, which makes this an equilateral triangle. So each side is 1, including on the bottom. But the line coming down, the 2 sides, the shared side is actually a segment bisector. So we end up with the legs on the bottom being 1/2. So isolating that triangle, what we can do with our bottom leg of 1/2 and our hypotenuse of 1 is the unknown side can be x, and we can apply the Pythagorean theorem to this. And what you can see after my really fast writing is that that longer side, the side opposite the 60 degrees, is square root of 3 over 2. So we can place that inside of a unit circle, and what we get in the first quadrant are the coordinates 1/2, because that would be the horizontal base leg, and then the longer vertical leg is going to be square root of 3 over 2. Of course, we can place those into all 4 quadrants, and then what's changing is the sign. So the analog for 60 and 60 degrees, which is pi thirds in the first quadrant, The analog in the second quadrant is 120 degrees, which is just double 60 degrees, and that equals 2 pi over 3. In the third quadrant, we have 240 degrees, which is equal to 4 pi over 3, and in the fourth quadrant, we have 300 degrees, which is 5 pi over 3. We can actually just flip the triangle around to get the case with 30, and in that case now the base leg is square root 3 over 2 and the vertical leg is 1/2, and we rotate those around the 3 quadrants as shown. We'll also talk about this in class, but this is just in case you needed a quick review. I hope it was helpful.